Bonk. See, and it even stopped raining. What are you talking about? Ain't raining. Making a big deal about, oh, it might rain on you. Don't get your board wet. Psh, get out of my face. Oh, this time on What's It Gonna Do Now? AI edition. We are gonna... I cheated. I got code. I got code to work. So what I'm gonna have it do is I'm gonna take the code that I know works. And then I'm gonna take the because it's a jank, blah, 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 putting all this stuff everywhere. So what I'm gonna do is I'm gonna take the code that I know works, and then I'm gonna put the cube libraries in a different location, and I'm gonna say, hey, Mr. AI person, let's create a CMake file that'll actually compile my code with that library and get all the paths and everything right. Because I was like trying to do that because janky, so I was trying to make it like, okay, let's do official. But man, so it's going to print hello world on my STM32. You're going to say, you shouldn't be out here. It's raining. Tell me I live my life. AI. But so yeah, so we're going to have it print hello world. And I know that I know my code works. And it's going to print hello world to the screen. And I know it works because I've done it. And I've done it with the STM32 cube libraries, but it's like, it was all jank backward stuff. So we're going to make it real. We're going to make it legit. So I'm going to ask the AI to make my code legit. All right? I'm Ryan Torbic, Tulip Tree Technology. Let's see what this thing does. Oh, there it is. Okay, so what I've already done is I went through and I copied my code over into this directory. Then I went and git cloned this, the STM32 cube F7 git, recursive, branch, depth, all that stuff. And then I used my EO init to create a dev container for this guy. And then the template's been successfully applied. So we've got our build toolchain inside there. So all I have to do is open it up in VS Code. Here's our VS Code. Call it aware koala. And then it's going to say reopen in container. Showlog. All right, trash that. Trash that. All right, we are ready to go. So I've got my core directory, and I've got my STM32 cube F7 directory. 36 submodules, which won't what? Won't be able to, you can still open each one individually, open a file within. That's interesting. Oh, because it's gonna, oh, thank you, VS Code, for not going through and scanning all this stuff. 36 submodules. So I've got my core here, which has got some stuff in it. And I got an include, which has some stuff in it. And I know that I can compile this against other, if the stuff's in a different location, but let's have it make a CMake file. So let's go and then put my ROO code in here. Come on down. You're the next contestant on What You Gonna Do. All right, goodbye there. Let's check. We're still using Gemini. Yeah, it's fine. Let's keep playing with Gemini. No problem. All right, so a good prompt. Okay, so I have an STM32 application, and I need to link up to the STM32F7 cube library. Please make a CMake file that will compile my library, include another CMake file that will set, well, maybe I should change the order of these. I'm gonna copy this because maybe it'll go sideways. I'm gonna say enhance prompt with additional context. See what happens. But make a CMake and then include another CMake file that will provide the link and include flags for the directories that I need from the STM32F7 cube library, and also a CMake file that will specify the ARM none GCC compiler. Oh, I should probably point out that it's an STM32F746 Discovery board. What is taking so long? Interesting. Oh. All right, here we go. Whoa, it has dumped a bunch of stuff out. Okay. Generate and complete a robust CMake file for the... Okay, that's not true, so I'm going to take that out. Okay, that's fine. That's fine. main project file. All right, I'm going to take out this section here. Source code for my project is in the core directory. So I added to it, deleted that directory structure stuff. Source code for my project is in the core directory. My target board is an STM32F746 Discovery. Okay, now look at the rest of this. So file content requirements. So there's going to be an arm none EABI CMake.CMake file there. Okay, so it's going to do obj copy and dodge dump, essential compiler flags for the STM32F7. So that's got those set up in there. Find related commands, interesting to search. All right. This is the STM32F7 CMake, a single function, set up STM32 target. It's going to find the HAL driver. Okay. Target sources. Interesting. Okay. And then the main one, define the project name. We're going to call the project name aware koala. Languages, executable target, and for source files located in the core/source directory. Okay. Target specific compile options, target specific link options. Yep. Add custom command that runs after the build is complete to create bin and hex from the original elf. Absolutely. 3 complete and fully functional CMake files that can be used to build the all right, go. Subtask, dumping out the arm none EABI CMake. Good job. Looks good. Toolchain prefix, blah, blah, blah. Yep. GCC, G++. Oh, and the assembler too. Yep. Yeah, I ran into that before where I tried to use some other assembler and it was like, all right, so there's a STM32F7. Did you verify that those are accurate? I think you're going to need more than that. You're going to need the board support packages in there too. Which are in there. Okay. You are done. Is that what you said? You're done? All right. So, and then that task is over. So we've done this. Okay. I'm gonna copy these. All right. Great. Start new task. All right. So now we're going to say run the CMake command. We're going to say CMake build -s, blah, 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 and then CMake -- build build. Okay. And we use and we've seen before where it's like, oh, what directory am I in? I don't know what directory I'm in. Blah, let's just make a weird thing happen. So it specified on the command line that the directory it should be is the build directory. Okay. Oh, went to debug. Okay. Yep. Cool. Whoop. Look at all that. All right. So this is the undefined reference. Oh, it's because we're cross-compiling, so you shouldn't do that step. The linker is missing implementation of standard C libraries that are not available in the bare metal environment. I will add the no to the linker flags. This tells the linker to use a library with an empty stub implementations of these functions that resolve undefined references. All right, so you did that. Okay, go to town. Sweet. What did you just do? Target include, oh, yeah, the INC is not capitalized. Did it not care that it wasn't capitalized? Okay, so what is it doing now? Oh, yeah, don't do that. All right, where are you? Are you done? No, please. You are right. It is better to keep project-specific configuration in a different place. Okay, so remove them from there. And then put them over there. Let's just add in the discovery. Sweet. And you're ready to go again. Run command. Well, that was, there it goes. It's building stuff. Oh, thank goodness. I thought it was going to work that fast. All right, so there's a format is bad def sim. Yeah, oof. Gosh, I hate it when I have a bad def sim. Okay. Simplest way is to provide this for the definition of standard practice. This will change. Okay, so it put the def sim thing in the wrong place, the wrong flags, because it got passed to the assembler. Okay, sure. Sounds good. Bad def sim again. I will now reapply the fix. You don't think it worked before? Wow, not very many compile warnings. Unknown option -G3. I'm guessing you're sending a lot of those linker commands to the assembler, the linker flags. And it's like, don't do that. To fix it, user generated expressions. What was that? What'd you do? Are only users C specific flags are only applied to C files, and the assembler gets its own set of flags. Oh, okay. Oh, interesting. Wasn't the error? Was the -G3s in there? Or is that a dash or a minus? It's the same error. Come on, man. What's it gonna do? Still doing it. Still got the -G3 in the ASM flags. You just moved it to a different location. Dude. Unknown option -G3. Yeah. No kidding. Oh, you want to use the GCC as the assembler and access as driver will correctly pass the -G flag to the underlying assembler. Let's see what you did. Oh yeah, GCC. The assembler is GCC. Okay. All right, go to town. Unrecognized command line option, just GC sections. Did you mean data sections? -WL. Yep, don't forget that. 100%. Linking the C executable. Run command. You forgot the linker script. Yep, go find it. Did you find it? I found it. It's like all over the place. There's like a ton of them. You can just put it there. All right, you can put it there. I'm just gonna go and see what happens. All right. NGHX_LD. What'd you do? I reviewed target link directories. Oh, so it's got to be in the link directory. Let's target link directories. CMake source dir. Yes. Run command. Sweet. Different. Good. Different. Bunch of undefined symbols. Or repeated symbols. What? What's happening? Classic case of template file hell in STM32 development. What? The build is failing with multiple definition errors because the HAL template files are being compiled alongside the user's provided ones. There are undefined references because of the necessary board support package. The source files are not being compiled. Like, yes, that's true. So what did you do? I've applied the necessary changes. There's a board support package. There's the include directory. Oh, there's some BSP sources here. Is that it? That's all you did? All right, run command. Good. That's done. Whoa. Thank you for resolving fixed linker errors, resolved header and source file issues. Corrected. Okay. How do I? Cool. Nice. Okay. Linker script, compiler, and assembler configuration, header and source file issues. Look at that. It's all there. I wonder where my whatchamacallit is. Oh, they're all three there. It just didn't print anything out. So there's a bin, there's an elf, and there's a hex. All right. Now, this is inside a dev container, so we're going to have to switch over to my warp. So now I'm going to say fix install code slash my bin. Yeah, pretty simple. Just flash it to the board. Let's see what happens. What are you going to come up with? I'll help you flash your binary to the board. Let me check what files are available in the current directory. Not there. Compiled binary and build. Thank you for finding that. Okay, which st_flash. Yep. Oh, no board connected. Hold on. Let's try again. Okay. One. I did one. Do you know what that means? Great. I'll check your STM board now. It's detected. Okay. Probe. Thinking. Perfect. What happened? There's a flash loader. First resetting the board. Ah, yes. Yes. I saw that. It was like st flash and then -- reset. Yep. Go ahead. Thinking. Flashing with success. All right, so what we have done, I forgot to switch back over. It did a nice job. It did a nice job. It did a really nice job. So we're going to go back over here, start new task. And so I said to make the font size bigger. I said, please make the font size in my Hello World project significantly bigger on my STM32 board. Okay. So it broke down the task of like locating the main application in the source directory, find out where Hello World is printed out, specify the file on the line of code that changes the font, and then task. So that would be one task. And that task came back after it found everything. Then it said, okay, we're going to actually add this BSP LCD set font in there. Okay, and it selected font 24. So then it set that the BSP set font should contain 24, and then replace that with font 24. Yep, save the changes, etc., etc. All the subtasks are done. Okay, so it did that, and then I asked it to build it, and I had some back and forth with, no, don't do it with directories. Directories are dumb. And eventually it figured out the -b build, and then -- build. And then it built it. Now somehow this showed up, but like, whatever. Yep, it's still connected. Good. Flash your updated binary. Go ahead. Oop, failed. And this, it does this. Okay, ooh, erase. I'm gonna hit the reset button now. Yeah, so it doesn't have it on there anymore. So it continued to say, and then I hit the reset button. Okay, run. Perfect. Successfully flashed. Okay, we're going to click the button. And it's the same size. I wonder if it was already 24. Maybe we can make it go to the bottom or something. Let's go back over there and ask it to move it to the bottom instead. All right, so we're going to move it to the bottom and then have the background be black and the text yellow. Okay, simple. And that's it. Oh, it's got a bunch of stuff. What are you doing? Please modify it. Okay, main.c requirements. The bottom of the screen, black, yellow. Okay, context and instructions. Oh, and it's got some like, oh, you have to use this. Interesting. All right, go to town. Uh-oh. Include the correct BSP header. No, that was for the... Okay. Interesting. What did you do? What did you do? This is why you make commits. I could do a commit after everything. It's updated it. Set back color black, yellow, LCD clear, set font. Center mode. Y size -24, 0. Okay, so looks like it's trying. Okay. All right, cool. Let's go back to our warp. All right. Please reflash my project onto my STM32 board. Okay, still says hello world. Board is connected and flash it. Yep, it's connected. Okay, go for it. Oh, failed. I don't know why it does that. Erase. Cool. So it still says hello world, mass erasing. Hit the button. Ain't nothing there now. Now let's flash the binary. Flash. Thinking. Didn't say reset. So it's still white. I'm going to press the button. And it still says hello world the same way. What? What? It didn't work? It's the same binary. It's the same binary? Come on. Date. Okay, 3:30. It's from 7 minutes ago. It wasn't 7 minutes ago that should have built. What? Let's see. Oh, I didn't. It just made the modifications and didn't build it. Duh. Oh man, why are there so many steps to doing things? So many steps. Please build my project. No, no. Please build my project. What are you doing? Why are you reading the CMake list.txt? Just build. Oh my gosh, you're gonna make it again, but it's already there. Come on, man. Why gotta be like that? Okay, good. You did the -B build thing. Good. Thank you. I thought you were gonna change directory. Appreciate that. Compile the main, linking, all done. All right. Now we go over to the warp. Okay, you ready? Let's see. Yeah, it's just here. I'll just up and go to town. You know what? Just do that. Well, okay. Yeah, I know, but it did that and then I just do it again and now it's fine. You explain that to me. Okay. Oh my gosh. Oh my gosh. It actually worked. It actually worked. I just had to write the code myself. Okay. I'm not screaming. I'm not yelling. Not losing my damn mind. It's fine. It's fine. Everything's normal. That was supposed to work. That was supposed to work. It was supposed to do that. It was supposed to move it to the bottom. It was supposed to make it black and yellow. That's what it was supposed to do. What are you doing? It worked. 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 You know what? Cut, bait, and run. Snap, snap, snap. Boom, boom, boom. Cut, bait, and run. Let the fish go. Because I got enough fish in the back. Tons of fish. We got so much fish. I don't even know what to do with all the fish we got. Okay, so there you go. So we trimmed down what the AI needed to do. Because having it try to figure out all the initial, did I show you all the initializations? Here, let's go back. All right, so trying to get it to figure out main.cpp, what, like the whole thing from scratch, like from nothing. All right, so you need all this stuff here, and you need all this stuff here, and maybe you don't, but you do, and then you need all these things, and then there's your how init passes, system call config, and then it's brrr, brrr, and then you can do your user code begin here, and then there's a while loop. Like, so with all of this stuff written down already in advance, and keep in mind, I didn't write this. The whatchamacallit did. You know, I used one of them STM MX things, and it said create the product for me. So I did that. So that's where I got this, like the code for this to start with. And then we added, that was dumped out. That was just dumped out by the MX thing. This whole file was dumped out by the MX thing. And then all we did was add this stuff in here. Okay. And we added the header files that are necessary. We put those in main.h. After that, we didn't do nothing else. Okay. That was what we did. But expecting the AI to figure out all that stuff and then try to debug it. Okay, you know what? Fine. I'll do the MX thing, I'll dump a file, and then it'll give me that. I only need those two directories, and then the STM32F746 cube package, and that's it. And then it figured everything else out, and now, we can start cooking with fire. We can say, okay, now let's do this with it instead. Now let's do this with it instead, and let's have it juggle, and let's like put our head down on the floor and dance, spin around and spit nickels. Like, yes, we can. All right, well, if you liked it, you excited too, hop down there, smash them the buttons, the like and subscribe buttons, smash them up. And yeah, it's a brand new day. It worked. Woo, 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 woo. We'll see you next time.